Hey everyone, I hope you're doing well today. In this video, let's do a little bit of review of pre-algebra to help you get ready for Algebra 1. And I'm going to cover all these 8 different topics in the course of 75 different questions. So if you want to go ahead and do these with me, perfectly fine. Grab some paper, pause the video, something to write with. Otherwise, let's just jump right into it. All right, so in part 1, we're going to start with some positive rational numbers. The word product means multiplication, so we're just going to go ahead and multiply here. So I'll go ahead to the right and write 426. You write the number with more place values on top and the one with less place values on bottom typically. Okay, and then we're going to start with this 5. 5 times 6 is going to be 30, carry the 3. 5 times 2 is 10, plus 3 is 13, carry the 1. 5 times 4 is 20, plus 1 is 21. Okay, so go ahead and done with those numbers. You can cross them out if you want. Cross out that 5, 3, and 1. And you can move over and talk about this 8, which is really an 80. So if you want to put a placeholder, that's fine. 8 times 6 is 48. I'm going to carry the 4. 8 times 2 is 16, plus the 4 is going to be 20. Carry the 2. 8 times 4 is going to be 32, plus the 2 is going to be 34. Go ahead and add these two rows together, and that should be our product. So that's 0. 8 plus 3 is 11. That's going to be a 2. That's going to be a 6 and a 3. So you can put the comma right there if you'd like. But the product here is going to be 36,210. Okay, for number 2, we're going to have the same idea here. We're going to find the product, but this time we're going to deal with decimals. Remember, you can just ignore the decimals when you're multiplying and then just deal with them at the end. I'll write them, but we'll just try to ignore them. Don't line up the place values because that's not necessary. Just line up the number of numbers. Okay, so I'm going to go ahead and start with this 7 here. 7 times this 9 is going to be, what, 63? Put the 3, carry the 6. 7 times 4 is 28, plus the 6 is going to be 34, carry the 3. 7 times 8 is 56, plus the 3 is going to be 59, carry the 5. 7 times 5 is 35, plus the 5 is going to be 40. Okay, so done with the 7, done with these carried numbers here. Moving on to working with this 2, which we're really think about this as a 20, so that's the 0. 2 times 9 is going to be 18, carry the 1. 2 times 4 is 8, plus 1 is 9. 2 times 8 is 16, let's put the 6 and carry the 1. And 5 times 2 is 10, plus 1 is going to be 11. Okay, so we'll go ahead and just add these two rows together, just like we did earlier. 3 plus 0 is going to be 3. 8 plus 4 is going to be 12. We'll carry the 1. 9 plus 9 is 18, plus 1 is 19. Carry the 1. 1 plus 0 plus 6 is a 7. This will be a 5. This will be a 1. Okay, so if you're wondering about the place value earlier, well, there are 2 decimal places over here, and there's 1 decimal place here. So that means we need to have 3 decimal places in our product here. So our final answer is going to be 157.923, or 157 and 923 thousandths. Okay, there you go. All right, so let's take a look at number 3. So we're going to find the quotient of these two numbers, which means we're going to divide them. So we'll take this 7,839, and we'll divide that by 13. So if you want to try this on your own, go for it. If you want to just watch, that's fine too. 13 doesn't fit into 7, so you can either leave it blank or put a 0. Then 13 times what gets you close to 78? Well, I'll go ahead and just write it out, but let me try 6. I think that might get us close, if not actually be the number. That's going to be 78, so 6 is the number we're looking for. So 6 times 13 is exactly 78, and we subtract to see what the remainder is going to be. It's going to be 0. Okay, then we're just going to go ahead and bring down the next number and then just repeat this process. 13 fitting into 3, that's going to fit in 0 times. So we're going to say that goes in 0 times. Always see how many times it goes in on top. That's a 0. Remainder is 3. Then we'll go ahead and try this one more time, but we have to bring down the next number. Repeat the process. 13 times 3 is going to be 39, right? So 3 times 13 is 39, and we have a remainder of 0. So our final quotient here, 13 fits into this big number 603 times. That's the quotient. Okay. One more dividing problem. So the quotient of these two numbers. Just keep in mind that when we are dividing, we actually like this number, the number that's going to be on the outside, to be a whole number. So let's go ahead and multiply it by 10, because that's going to slide the decimal over and make it 23. Okay, but if we do multiply that one by 10, we should also take this number here and multiply that one by 10 as well. If we do that, then we are going to get the correct quotient So it's going to be 2 and then 0.91. So both of them, their decimals slide over. This makes the long division a lot easier to deal with. So we make the division house 152.91 divided by this 23. Okay, so just go ahead. Don't feel like you have to move the decimal when you're done back at all in any way. You don't need to. You just have to divide, and whatever your answer is, it's going to be correct. So take this decimal and just bring it up here. It's in the correct spot, I promise. Okay, so 23 doesn't fit into 1, and it doesn't fit into 14. So you can skip those, or you can go ahead and put placeholders if it makes you feel better. Okay, then we'll go ahead and see 23. We got to go to 145. So maybe times 6. That should get us close. That's 18, carry the 1. That's 138. That sounds good to me. So if it's in 6 times, and that'll be 138, that's very close. As close as we can get, I think, without going over. And if we subtract, that's going to be a remainder of, I think, 7. And we'll go ahead and bring down the next number and just repeat this process. 23 times what gets you 72 without going over? How about 3? I think that's going to be 9, and that will be a 6. 69 is pretty close to 72, right? So we'll put this 3 here, and that's going to be 69, we just said. And if we subtract, the remainder should be 3. Go ahead and bring down the next number, which is this 9. We'll repeat the process. 23, if you double 20, that's already 40 something, so it only goes in 1 time. So I'm just going to put a 1 right up here. Okay, 1 times 23 is 23. If we subtract, we should get 16 as the remainder. And I think we'll go one more time here. Let's bring down this 1. This is now 161. And I'm going to try 7, just because I know 7 times 3 is 21. So 23 times 7. It's 21. Let's carry the 2. That's 14 plus 2 is 161. So that checks out. So we're going to go ahead and put a 7 up here, because that's going to be 161, and the remainder is 0. So the quotient here is going to be 63 and 17/100ths, or 63.17, but that'll be the quotient, or what the answer to the division problem is. Okay, nice. So that's the first few problems. For number 5, what are the first 10 prime numbers? Well, the first one is 2, and then that's the only even one, by the way, so that's kind of unique. 3, 5, not 6, 7 is prime, not 8, not 9, not 10, 11, not 12, 13 is prime, 14 is composite, 15 is composite, 16, 17 is going to be prime, 18 to 19 is prime, 20, 21, 22, 23 is prime, 24, 25, 26, 27, 28, 29 is prime. I think that's 10 numbers, right? Remember, there's infinitely many prime numbers, but those are the first 10, I believe. Okay, they have exactly 2 factors. The first 10 composite numbers, the first composite number is going to be 4. 5's prime, 6 is composite, 7's prime, 8's composite, 9 is also composite, 10, basically going in between the prime numbers now, 12, 14, 15, 16, 17, nope, 18. How many is that right now? 1, 2, 3, 4, 5. Oh, I think that's 10 numbers. But these are all composite numbers. They have more than 2 factors, but not an infinite amount. So there are, for number 7, let's talk about, it says which numbers are neither prime nor composite. So there's 2 numbers that you want to be aware of. The number 1 is not prime nor composite, and it's because it has only 1 factor. All right, prime numbers have 2 factors, but the number 1 only has 1 factor, which makes it a little bit more unique. And the other number you want to be aware of is the number 0. So the number 0 has infinite factors. Infinite. So it's important to know the distinction here, because prime numbers have to have exactly 2, and composite numbers have to have more than 2, but a limited amount. Can't go on forever. 1 is special because it only has 1 factor, literally just 1, and 0 has infinitely factors because anything times 0 is 0. So these 2 numbers are special, and they come up a lot more with the identity property later down the road. Okay, prime factorization. Let's see if we remember how to do that. That's where we break up the number 24 or any number into a product of all its prime numbers. So 24 would equal 2 times 2 times 2 times 3. You could also write this as 2 to the third power times 3. Now, if you had forgotten how to do that, right, you can totally go ahead and make a factor tree, like 6 times 4 is 24. You can choose any two factors that multiply, and you just keep breaking down the factors until they're all prime. So you see here, I just made a factor tree, and all the numbers at the bottom, you break it down into its basic building blocks, and so that would be the prime factorization. Okay. For number 9, we're going to find the prime factorization again, so it's very similar. So we'll take this 45, and that's equal to, I know 3 is prime, times 3 is 9, 9 times 5 is 45. If you want to use exponents, you can say 3 to the second power times 5. That's fine too. If you want to see the work for this 45, pick two numbers. 9 times 5 is usually what people think of. 5 is prime, so you get to circle it. 9 breaks into 3 times 3. And those are your prime factors. So that's the prime factorization. Okay. If you ever see a number that is prime, like 17, the prime factorization of 17 is just 17. That's all you got to do. You don't need to write 17 times 1 or anything. Just write 17. Again, 1 wouldn't be in the prime factorization because 1's not a prime number. Okay. First, for number 11, we'll talk about the factors, and then we'll talk about the multiples of 18. Okay, so factors of 18. What's really useful to start here is if you can get the prime factorization for 18, which is going to be 2 times 3 times 3, right? If you have the factors, then if you have the prime factorization, then coming up with the factors is very straightforward. Okay, so let's see why that works. So if we have 18, well, factors of 18, 1 times 18 is what you should always start with, right? But then if you group this and say this is 2, and this is going to be 9, right? 3 times 3 is 9. Then you know 2 times 9 is going to be 18 as well. Okay. Now, you don't have to group them that way, though. Like, what if you were to group them slightly differently? You can say 3 times 2 times 3. Well, 2 times 3 is 6, so you can say this is 3 times 6, right? So you can group any prime factors to get other factors of 18. Okay, 4 won't work because you need 2 2's for that, 5, 6, 7. I think that's it. All right, so these are all the factors of 18. Okay, I'll write that down here. These are the factors. And I can ask you for all the factors, or you can be asked for all the factors because there's always a limited amount for these numbers, right? For multiples, it's slightly different. The first multiple of 18 is going to be 18 because it's 18 times 1. Then 18 times 2 is 36. 18 times 3, I think, is 54. 18 times 4, I think, is 72. 18 times 5, I think, yeah, it's 90. And so these go on forever, but these are just the first 5. So you could be asked for all the factors, but you can't be asked for all the multiples. The multiples go on forever. Okay, let's check out number 12. And feel free, again, if you want to pause and try any of these on your own, that's good practice, but totally up to you, whatever you want to do. 72's prime factorization. I know I can divide it by 2, that's 36. I can divide that by 2, that's 18. 18 can divide by 2, that's 9. 9 breaks into 3 and 3. Okay, so let's try to get all the factors. And again, if you need to make a tree, go ahead and make the tree. But I'm going to start with 1 and 72 because those are always going to be factors. Then I'll go with 2 times all of these numbers. So that's going to be 2 times 36, right? And then after that, we can go with maybe 3. So it's 3 times whatever these are. So 3 times 2 times 2 is 4, times 2 is 8, times 3 is 24. This beats dividing, so multiplying is a little bit easier, I hope. I don't see 4 on the list, but again, you can make 4 by doing 2 times 2. So I know 4 is going to be on the list here. And what about the rest of these? 2 times 3 is 6, and 6 times 3 is 18. So 4 times 18 is going to be 72. Usually people miss that one sometimes. 5 is prime. It would be on the list, but it's not. Let's see. These two together make 6, so 6 is definitely on the list. And what about the rest of them? 2 times 2 is 4, times 3 is 12. That makes sense. 6 times 12 is 72. Okay, and then 7 is prime. It would be on the list. 8 is 2 times 2 times 2, right? That's 8. And then 3 times 3 is 9, so 8 times 9. So we like using prime factorizations to help us find all the factors of a number. That's a complete list right here. Okay. What about the multiples of 72? So if we do multiples of 72, 72 times 1 is going to be 72. 72 times 2 is going to be 144. 72 times 3 is going to be 216. 72 times 4 would be, I think, 288. And 72 times 5, I think, is 360. Okay, so those are the first 5 multiples of 72. Always start with 72 as your first multiple, since 72 times 1 is 72. All right, let's get into some applications. So GCF is going to be one thing. That's the greatest common factor. And LCM is the least common multiple of 8 and 12. So let's take 8 and let's take 12. 8 is the same thing as 2 times 2 times 2 if you write its prime factorization. And 12 is going to be 2 times 2 times 3. So we'll use and apply what we were just talking about. What do they have in common? Well, they both have these 2's and they both have these 2's. So what do you do for that? Well, for the GCF, you just multiply those together. So you can just say the GCF here is going to be 2 times that 2, which is equal to 4. And if you want to go ahead and find the LCM is going to be this 4 that we just came up with, right? And it's going to then multiply by all the extra numbers that didn't get paired up. So this 2 and 3. So multiplied by 2 and multiplied by 3. So 4 times 2 is 8, and 8 times 3 is going to be 24. So there we have the GCF, which is going to be 4. This is the biggest number they have in common as a factor. And if you were to write their multiples out, this is the first multiple that they meet at. Okay, that first special time they meet. Okay, there's a shortcut to this. If you don't want to use that method, you can take this and use the ladder or the cake method, which is where you stack them. So you write them side by side. What goes into both of these numbers? If you can only think of 2, go for it. Write a 2. 2 goes into 8 4 times. 2 goes into 12 6 times. You can then go ahead and do this again because 4 and 6 are not relatively prime. They have more common factors like 2. 2 goes into 4 2 times, and 2 goes into 6 3 times. At this point, 2 and 3 have nothing left in common besides 1, so this 2 and 2, that gets you the GCF if you want to multiply. And for the LCM, what you can do is you can go ahead and multiply all of these numbers on the outside. Kind of looks like an L for LCM, but if you multiply all of these, you will get the LCM. One little side note and a shortcut is if you just multiply these diagonals, 12 times 2, that'll always get you the LCM, and 8 times 3, this will also get you the LCM. All right, cool. So that was number 13. Let's check out number 14. So again, we're going to find the GCF and LCM. So practicing one more time with more numbers or different numbers. So 18's prime factorization is going to be 2 times 3 times 3. Again, go ahead and make the tree if you need to. And for 27, we have 3 times 3 times 3. I think that's 27. Okay. What do they have in common? Well, I think they have these 3's in common, right? You got this. And this one also, these 3's are in common. So what is the GCF? It's the product of what they have in common. Again, it's called the greatest common factor, so it's what they have in common. And 3 times 3, that's going to equal 9. And for the LCM, what are we going to do? If you remember from just a moment ago, what did we do? We took the GCF, which was 9, and then we multiplied it by the extra numbers that didn't get paired up. So that 2 and that 3. So that 2 and that 3. So 2 times 3, I'll do the purple ones first. That's 6, and 6 times 9, that's going to be 54. So GCF, 9, that's the biggest number that goes into both. But then 54 is the smallest number they go into. So slightly different concept, GCF versus LCM. So if I want to show you this other method here as well, if you can think of a bigger number like 9 right away, then go for it. I kind of already know because I just did the problem, so just go straight to it. And again, like this is going to be the GCF on the side, and this will be the LCM. If you multiply these, you should hopefully see the similarities. Or you could say 27 times 2 is 54, 18 times 3 is also 54. So hopefully that helps you remember and refresh how to find the GCF and LCM. For number 15, now we're talking about fractions. So 45 over 4, you just want to remember that that technically means 45 divided by 4. So if we're doing division, we can use long division. So 45 divided by 4, let's see, 4 goes into 4 one time. 1 times 4 is 4. You can subtract, we're left with 0. You can bring down this 5 here. 4 goes into this 5 one time. So 1 times 4 is going to be 4. And the remainder here is going to be 1. So as a mixed number, it goes in 11 full times. Okay, that's 11 as the whole number. This 1 down here is going to be the remainder. So we'll go ahead and put that 1 as the remainder. And then this 4 is what we're dividing the pieces into. So it's going to be 11 and 1/4. So this is the equivalent, but it's a mixed number version. So whenever you try to convert an improper to a mixed number, just use long division and you can get there pretty easily. Okay. For number 16, what if you're trying to go backwards? Well, if you take this 5 3/4 and you want to make that back into an improper fraction, the shortcut here is just you take the whole number, 5, and you multiply it by the denominator. That's the pieces you're cutting it into. And then we're going to add the numerator here. So we're basically going to say 5 times the 4 plus the 3, but we're going to keep this whole thing over 4. Okay, so if you then go ahead and multiply 5 times 4, that's going to be 20 plus the 3, that's over 4. And then 20 plus 3 is going to be 23/4. This would be the improper fraction version. If you want to check this, you can use long division and divide 23 by 4, and you should get back to 5 3/4. Okay, so for number 17, we're going to now simplify this fraction, but we're going to use the GCF. So that's important that we're going to be using that concept. So if we take 45 and 60, the goal here is to use the GCF. So let me show you how you're going to do this. So if you need to make a factor tree, go ahead, but I'm just going to write the prime factorization. So I know 45 is 9 times 5, and 5 is a prime number. 9 is not. 9 breaks into 3 times 3. So that's the prime factorization for 45. For 60, I know that's 6 times 10. They're both composite though. 6 is breaking into 2 times 3, and 10 breaks into 2 times 5. So there's the prime factorizations for each of these numbers. And let's take a look at how we simplify using the GCF. Well, let's find the GCF. So these two numbers pair up, so that's 3. And you can also notice that these 5s pair up. And so the GCF here, we can say the GCF is going to be 5 times 3, and that's equal to 15. So we can then go and say, okay, if that's a common factor or the greatest common factor, we can divide by both of these. But wait, do not actually do the division. The answer to the division problem is just going to be this leftover number of 3. 45 divided by 15 is 3. And on the bottom, multiply these two leftovers. 2 times 2 is 4. And it turns out that 60 divided by 15 is equal to 4. Okay, so this, as a most simplified version, is 3/4. Okay, as long as you can get the prime factorizations, you can do that quickly. If you want to use the ladder method, you can also do that as well. If you go ahead and write the fraction like this, right? Hopefully you know you can divide both of these by 5, and that would be, what, 9 and 12. And then you could take 9 and 12 and divide both of those numbers by 3, and that would be 3 and 4. So while that's a shortcut, it is good to know the prime factorization method as well. I'm just showing you both to hopefully give you some review to strengthen your understanding. Okay. If you want to pause and try 18 on your own, feel free to do so to see if you got it. If you want to just take a peek, that's fine too. All right, so what do we got here? 48 divided by 2 is 24. 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. Did I do that right? I think so, yeah. 72 divides by 2, that's 36. Divides by 2 is 18. Divides by 2 is 9. 9 is 3 and 3. Okay, so there's the prime factorization. And let's see what they have in common here. They have a 2 in common. They have another 2 in common. They have another 2 in common. And they have a 3 in common. So what's the GCF here? Well, 2 times 2 is 4, times 2 is 8, times 3 is 24. So the GCF here is going to be 24. If that's the GCF, that means that by definition, we can divide both of these numbers by it. But if you don't want to do division, 48 divided by 24, it's just equal to this leftover number here of 2. And 72 divided by 24 should just be this leftover number of 3. So if we did this correctly, that should always check out. Okay. For the ladder method, feel free to take 48 and 72, write them like a fraction like this with a slash, that's fine. If you know 8 times 6 is 48 and 8 times 9 is 72, that's a nice number to use. And then 6 and 9, I think those are both divisible by 3. And that would be, if you divide by 3, that should equal 2/3. And that's the same thing. So definitely less work, but you have to know your multiplication facts a little bit better. Okay? Cool. So number 19, let's talk about adding fractions. Okay, these are not so nice because you need common denominators. So if you take a look at this 8 and 6, you have to find something called the LCD or the LCM of these two numbers. So you can go ahead and take this 8 and 6. I'm just going to use this ladder method to be super quick. So 2 goes into both of those. This goes in 4 times and 3 times. And then if you just go ahead and multiply these outside numbers here to get the L, 2 times 4 is 8 and 8 times 3 is 24. So we know the LCD, or least common denominator, or least common multiple, is equal to 24. So how do we get this fraction to have the same denominator? So we need the same pieces on the bottom so that we can actually add. To get to 24, what we can do is we can multiply 8 times 3, and that's this diagonal here I was mentioning earlier, but if we do to the bottom, we should do to the top. And over here, we can do 6 times 4, so that's why the ladder method is also helpful. But this way, we're going to get common denominators. So 7 times 3 is 21, 8 times 3 is 24, 1 times 4 is 4, 6 times 4 is 24. Now that we have these equivalent pieces on the bottom, like it's important that these match so that we're adding the same size pieces. That's going to be 21 plus 4 is 25 over 24. And if you want to write this as a mixed number, that's also fine. But keep in mind that typically in middle school, high school, we don't mind improper or mixed numbers. They're both good. We actually use improper ones a little bit more in algebra. Okay. For number 20, we need common denominators again, so a little bit annoying. We are subtracting this time though, so it might be a little bit trickier with borrowing and stuff like that. 9 and 6. Okay, so let's take 9 and 6 and see when they meet for the first time. I think 3 is a common factor, and we go 3 and 2. So when do they meet at the first time? So I think that's going to be 18. So let's go ahead and use 18 as our LCD. So we have this 3 and 2/9, and then we're going to subtract this 2 and 5/6. Okay, and we know we need to get to 18, so how are we going to get to 18? Well, for the 9 times 2 gets you that 18, so it's times 2 and times 2. And how is the 6 going to get to 18? Well, it's just times 3 and times 3. Alrighty, so 3 and then 2 times 2 is 4, 9 times 2 is 18, minus 2, and 5 times 3 is 15, and 6 times 3 is 18. So what the goal is, what we just accomplished, is we got these denominators to match, so we can technically add and subtract now. Now, here is a little bit of the issue, all right? Notice how we have this 4 here and this 15, and we can't really take away 15 from 4 very nicely. So what we generally do here is we regroup, okay? And when I say regroup, we're going to take 1 from the 3 and make it a 2. We're going to make this 2 and 18/18 plus 4/18 minus this 2 and 15/18. All right, so just keep in mind that this value right here, or this 18 over 18, right, this is the same thing as 1. And so if you add that 1 to the 2, it's technically still 3. Okay, so, but by regrouping, this makes it easier to actually subtract. So this is 2, and 18 plus 4 is 22. So it looks strange because we have an improper fraction inside of a mixed number, but we can use this temporarily. Okay, so now notice here that this 22 is now actually bigger than the 15, and it makes it so it's easier to subtract. So subtracting the whole numbers, 2 minus 2 is 0. 22 minus 15 is 7, so 7/18 would be the final difference here, or the answer to a subtraction problem. Okay, so there you go, that's number 20. Moving on to the ones I like more, which is multiplying and dividing, because we don't need common denominators. It's a lot less picky. Okay, so the product means we're multiplying, so that means we're taking this 12 over 18, and we're multiplying that by this 27 over 15. So I'll show you two ways, one slightly longer and then the actual answer. And you can just go ahead and write the prime factorizations of both numbers. So 12, that is 2 times 2 times 3, right? 2 times 2 is 4, 4 times 3 is 12. And 27 breaks down into what numbers? 27 is 3 times 9, but then the 9 breaks into 3 times 3. So I just broke down each of these numbers into their prime factorization. So far 12 became these 3, that's the prime factorization, and 27 broke down into 3 times 3 times 3, that's that prime factorization. Taking a look at this 18 here, 18 would be 2 times 3 times 3. Okay, that's going to be 9, 9 times 3, 9 times 2 is 18. Good, so that makes sense. And then for 15 here, 15 is going to break into 5 times 3. Okay, that's that prime factorization. So I just broke them all down. And what's nice is you could just multiply 12 times 27 and 18 times 15, but what's nice is if you know their prime factorizations, you can just go ahead and cross out what they have in common on top and bottom. So they both have a 2 and a 2. That means you could simplify by that later, but we're just doing it now. 3 and 3, another 3 and 3, and another 3 and 3. So for our leftover numbers here, we can go ahead and multiply this 2 and 3 together. That's going to equal 6. And on the bottom, our leftover number here is 5, so it's just going to be 5. So that's the answer as an improper fraction, but as a mixed number, it's going to be 1 and 1/5. Either one of these are okay. Again, if you just wanted to multiply 12 times 27 and 18 times 15, you can. It's going to be a huge number, and then you're going to have to divide and simplify using the GCF and whatnot. But it's nicer to just be able to cross out what they have in common if you break it down first instead of getting bigger than going smaller. If you wanted to use cross-canceling, you totally can as well. So the way that works is you don't use prime factorizations, but you just look at these numbers. So 18 and 27, they both can be divisible by 9. So if you divide 18 by 9, it's 2, and divide 27 by 9, that's 3. Okay, and then you can also say this 3 and this 15, you can divide those both by 3, and you'll get 1, and then you'll get 5. And what else can we do? Oh, this 2 and this 12 can be divisible by 2, so you get 1 and 6. So then if you multiply this 6 times 1, you do get the 6 that we have over here, and this 1 times 5, you get this 5 over here. So if you can do that, that's pretty good because it saves you some time. You just have to keep track of the numbers a little bit more clearly. Okay, only cross out top and bottom. It doesn't matter if it's diagonal or top and bottom. Number 22, we're multiplying again, but we have 6, and we're multiplying that by a mixed number. So make sure you always convert these. So 6 is the same thing as 6 over 1. And for the 5 3/4, remember to convert to an improper fraction, it's 5 times 4, which is 20. 20 plus 3 is going to be 23. It's going to be 23 over 4. Okay, so no mixed numbers, no whole numbers. Make them improper or proper fractions if you can. Okay, now I'll show you both ways again here. So if you were to write the prime factorization, 6 is 2 times 3. And 23 is prime, so that's going to stay the same. And on the bottom, we have this 1. I'll just leave it for now. And 4 is basically 2 times 2. And so what do they have in common? They both have a 2. And I think that is it. Okay, so what are the leftover numbers here? So on top, 3 times 23, that's going to equal 69. And on the bottom, we have this 1 times 2, and that's equal to 2. If you want to write this as a mixed number, you can. You just have to use long division. So I'll go ahead and show you that just in case. One more time, divide by 2. Fits in 3 times. 3 times 2 is 6. Subtract, that's 0. Bring down the 9. 2 goes into 9 4 times. 4 times 2 is 8 with a remainder of 1. So this would be 34 and 1/2. There we go. Okay, if you wanted to cross cancel and not use prime factorization, 6 and 4, you can divide them both by 2, and then you get 3 and you get 2, and it works the same way. Okay, if you were to multiply 3 times 23, you get the 69, and 1 times 2, you get the 2. So same idea here, not a big difference. So that's 22. 23, let's talk about dividing a little bit. So dividing is pretty similar to multiplying. We just have one extra step. So we have this first fraction, and we're dividing it by 9 over 20. So you might remember something called keep, change, and flip. It turns out you can turn every division problem into a multiplication problem by using this algorithm, and then it becomes easier to solve. So we always keep the first one, and we change division to multiplication, and then we flip. It's kind of the easy way of saying it. It's called reciprocating, or flipping the fraction upside down. Okay, and now it just looks like a multiplication problem. So if you see a division problem, just try to remember keep, change, flip. You might remember, if you've had me, Kentucky chicken fried, just kind of make that up. And I'm just going to go into trying to cross cancel right from the beginning here. So 15 and 20 divide both by 5, we'll get 3 and 4. Again, you're doing something on top and something on bottom. 12 and 3, you can divide them both by 3. That would be 1, and that would be 4. And I think that's it. If you're tempted to cross out the 4 and 4, don't do it. They're both on top. So that's a no-no. So 4 times 4 is 16. 1 times 9 is 9. You can use long division if you want, but I know 9 fits into 16 one time, and it is 7 left over. So go ahead and do the long division if you want, but if it's not too bad, you can try to do it in your head as well. So go ahead and try one more division problem. So we're going to divide again. Keep in mind we don't like mixed numbers, so we're going to have to make sure we turn it into an improper fraction. So 4 times 3 is 12, plus 2 is going to be 14. So we can write this as 14 over 3 divided by, and 21 as a fraction, we can just write as 21 over 1. And if we go ahead and keep this one, change this one, and flip this one, then this will be 14 over 3 times this 1 over 21. So instead of multiplying across, which we technically can do, let's see if we can simplify first. Divide these both by 7, that'll be 2, that'll be 3. 2 times 1 is going to be 2, 3 times 3 is going to be 9. There is our quotient. Okay, you can fit 21 into 4 2/3, 2/9 of a time. All right, you can't fit it in a whole time because it's too big for it. Okay, so there you go. That's the conclusion of part 1 of this review on all of this pre-algebra. Okay, let's keep on going here for part 2. We have to go ahead and order, so put things in order, the following integers, which are positive and negative numbers, and 0. And we're going to do this from least to greatest and use a number line to do so. All right, so we'll go ahead and start by drawing a number line, and let's see if we can put some values in here. So 0, 1, 2, 3, 4, 5. I don't think there's, 5 is the highest number, so that's fine. And then 1, 2, 3, 4, 5, 6. I think that takes care of all of them. I'll write these numbers in if it's helpful. -3, -2, -1, 0, 1, 2, 3, 4. Okay, so we have to plot these. So where's -3? -3 here is going to be plotted right here. Where's 5? 5 is over here to the right. -6 is down here to the left. 4 is towards the right side of this number line. 0 is right over here. -1 is to the left of it. And 2 is over here in the positive area. So just keep in mind that the more negative you go, they're bigger numbers, but if you have the negative sign, it's smaller, so it goes to negative infinity. And as you go to the right forever, you go towards positive infinity. So these are these numbers in order, right? So if you want to write them in order, -6 is smaller than -3 or less than it, which is less than -1, which is less than 0, which is less than 2, which is less than 4, which is less than 5. These are these integers from least to greatest. Okay. Talk about number 26, where we have absolute value. Let's talk about that first. Of 6, this just means how far is it from 0. And we use these bars to show absolute value. So if you ever see that, that means what's the absolute value of 6? How far is it from 0? You would say it is 6. Okay. It's just always going to be positive. Opposite of 6. So the opposite of 6, there's no symbol for this. I mean, technically it's a negative sign. Whenever you see a negative sign, it means opposite. So the opposite of 6 is going to be -6. Keep in mind, whenever you add opposites, you always get 0. For 27, let's try this again. Let's see if we have the absolute value of negative 13. So put negative 13 in these bars. How far is negative 13 from 0 is what you're asking yourself in your head. And you're saying it's 13 units. And what about the opposite? Well, the opposite of negative 13 is just going to be positive 13. Okay, it's just on the other side. So if you take away the negative, or if you add another negative, however you want to think about it, it's going to be positive 13. Okay, so while absolute values are always positive, opposites depend. Okay, all right. Let's order these from least to greatest using a number line. So let's go ahead and actually solve each of these. So negative 4, I think that's just going to stay the same as negative 4. What about the opposite of 6? Opposite of 6 is negative 6. What's this? The absolute value of 3, that's just 3. This 5 is going to stay the same as 5. What's the opposite of negative 2? That's just positive 2. And the absolute value of negative 7, that's positive 7. So we just have to order these numbers from least to greatest here. So here's a number line. Okay, we need to go up to 7, but down to negative 6. So let's see. We'll call this negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0. We'll call this 1, 2, 3, 4, 5, 6, 7, 8, just in case. So this is going in the negative direction. This is going in the positive direction. And let's go ahead and see if we can plot each of these. So negative 4 is located 1, 2, 3, 4. This right here is negative 4. And then the opposite of 6, that's going to be right here. How do I want to do this? I don't really want to write all of this out right now, so excuse my laziness there. And then let's see, the opposite, or what is this? The absolute value of 3. Maybe they use different colors if that helps a little bit. The absolute value of 3, sorry, is just 3. So that's right over here. Okay. What about 5? Well, that's just a normal 5. That's kind of boring. 1, 2, 3, 4, 5. I can write that one. That's not a lot. Not being very consistent. The opposite of negative 2, I think we said was 2, right? So that's right here. That I don't really want to write, so I'm going to put that here. That's the opposite of negative 2. And then finally, I'm running out of colors here. It says absolute value of negative 7, we said was 7. So that's over here. Okay, so these are these values from least to greatest on a number line. Okay, all right, moving on to 29. What quadrant is this located in? So if you forgot your XY coordinates, here's a little review for that. So if we have an XY plane, I'll draw a rough sketch here. So here's that Y axis, and then here is your X axis going from left to right and then up and down. And this negative 5, what does that mean? This negative 5 means that we are moving from the origin 5 units to the left somewhere. And then what does this 3 mean? This positive 3 means that we're moving up a certain number of units, 3 units, okay? If you forgot, this quadrant over here is called quadrant 2. So this point is located in quadrant 2. Okay. For number 30, where's this point located in what quadrant? So if we go ahead and take our XY plane here, what does this positive 9 mean? That means we're moving 9 units in the right direction. We always go left and right first. And what does this positive 4 mean? That means you move up 4 some certain amount. And so we are now located in quadrant 1. Okay. And number 31, let's take a look at this point here. So here's our y-axis, here's our x-axis. This negative 4 means you move to the left 4 units. And what does this negative 6 mean? It means you move down 6 units. This right here is quadrant 3. Okay, let's take a look at 32. Here's our x-axis and here's our y-axis. If we have this positive 6, that means we move 6 units to the right. And if we have this negative 1, that means we're going to move 1 unit down. This location would be in quadrant 4. If it helps you understand going forward, just keep in mind everything in quadrant 2 is always going to have a negative value first and then a positive value second. That's all points in quadrant 2. Everything in quadrant 1 is always going to be positive, positive. Okay. Everything in quadrant 3 is going to be negative, negative. Very sad. And over in quadrant 4, always the points are always a positive value and a negative y value. Okay, so hopefully that helps you review a little bit, and I'll draw this on the side here, but this is our x-axis. This over here would be our y-axis, and we call this our quadrant 1, 2, 3, 4, and we talked about how they go around kind of in a C in that motion, so 1, 2, 3, 4. Okay. All right, 33, we're going to talk a little bit about distance between 2 points. So if we were to visually take a look at this, well, I'll show you the shortcut first, I guess. These 2's match here, right? So these are nice points to use. If these 2's match, you're supposed to just take a look at this -4 and this 5 and see how far apart these numbers are from each other. So what you do is, if they're opposite signs, you take the absolute value of the first one and you add on the absolute value of the second one. The absolute value of -4 is 4, and the absolute value of 5 is 5. So 4 plus 5 is going to equal 9. So the answer is going to be 9 units apart from each other. Okay. If you wanted to look at this on a coordinate plane, I'm going to make a rough sketch here. It's not going to be perfect. So you can just visually see -4, comma 2. That means 1, 2, 3, 4, and then up 2. That would be located right about here. And 5, comma 2. So 1, 2, 3, 4, 5, and then up 2. This is visually where these 2 points are. So why do we add their absolute value? Well, here is the 4 units, or the -4. So here's the absolute value of -4. And then here is the distance of 5. Again, they're being compared to 0 here. So if you go ahead and add this 4, that's from here to here, and you add the distance of 5 from here to here, that's how you get the total of 9 units. Okay, let's go ahead and take a look at 2 points that are vertical from each other. So they're vertical when their x's match. And then so we're going to see how far apart are -3 and -9 from each other. Okay, slightly different because these are both in the same quadrant, right? -9 and -3 are both negative numbers. So if that's ever the case, you take the one that has a bigger absolute value and you subtract the one that has a smaller absolute value. So the absolute value of -9 is 9, and the absolute value of -3 is 3. So 9 minus 3 is going to equal 6, and that's going to be 6 units. Okay. Visually, why do we subtract here instead of add? Well, they're not on the opposite side of 0, so that's the key difference here. So here's the x-axis, here's the y-axis. 8 comma -3, that's 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3. That's that first point, and 8, and then 3, 4, 5, 6, 7, 8, 9. Roughly, this other point is down here. So the question is, well, how far are these 2 dots from each other? Well, if this one's at -9 and this one's at -3, they're just 6 away from each other. So they're not crossing 0, so you don't have to add a distance on the other side. You just subtract them. Okay. All right, that's 34. Let's take a look at part 3 now. Okay, so some algebraic expressions. We have an exponent here, so 3 to the 5th power is equal to 3 times 3 times 3 times 3 times 3. So 3 times 3 is going to equal 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3, I think, is 243. Okay, if you need to use standard algorithm, please do so. You should try not to use a calculator, but again, that's up to you. I think it's important to be able to do this on your own and just test your brain out a little bit. For 36, we have 2/5. This works the same way with fractions, so 2/5 times 2/5 times 2/5. If you know how to multiply fractions, like we said earlier, we can't cross cancel, but if we take this 2 times 2, that's 4, and 4 times 2, that's going to equal 8. And on the bottom here, we have 5 times 5 is 25, and 25 times 5, I believe, is 125. Keep in mind, if you're ever multiplying proper fractions together, it always gets smaller. For 37, we have 3/10 multiplied by 3/10 multiplied by 3/10. So remember, with multiplying decimals, you can ignore them. So what's 3 times 3? That's 9. 9 times 3 is going to be 27. So 27 is going to be in our answer. But we have 3 decimal places. So 1, 2, 3, right? They each have one. So our final answer here is going to be 0.027, or 27 thousandths. Cool. Now, a little bit of order of operations. If you forgot, parentheses or brackets always goes first. Exponents are always second. So that's going to be this. So I'll write this on the side, 2 to the 5th power. That's 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. It's 32. So we have 5 plus 8 divided by 4 plus 32. Then what's more important? Multiplication or division from left to right. That's going to be here. 8 divided by 4 is 2. So we have 5 plus 2 plus 32. Now we just have 2 addition problems, but we go from left to right. If they're equal importance, always go left to right. 7 plus 32, that's 39. There's our answer. Solving expressions. Keep in mind, we're just solving expressions right now. We'll get to equations later with equal signs. Expressions don't have equal signs. Take a look. Let's take a look. I was going to say check 39. Let's take a look at 39. This one does have a grouping symbol, so we'll start there first. This 2 plus 3. That's the most important thing to do in our order of operations. So 2 plus 3 is 5, so it's going to be 4 times 5. If you forgot, that means multiplication. The next most important thing, you can write 4 parentheses 5, but if it's confusing you and you think those are parentheses like grouping, it's only grouping one thing. You can change it to a dot for multiplication if you want. Okay. So no more grouping symbols. Exponents come next. So 3 to the 4th power, that's 3 times 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, times 3 is 81. So this will be 18 divided by 6 plus 81 minus 4 times 5. That takes care of all the exponents, and then we'll go on to multiplication and division. They're equally important, so left to right, 18 divided by 6 is 3. 3 plus 81 minus 4 times 5. Then multiplication is the next most important thing. 3 plus 81 minus 20, that's 4 times 5. Then we'll do addition first, not because it's more important, but because it is left. It's equally important to the minus or subtraction. Just happens to be there. 84 divided by 20 is going to be 64. Okay, so there you have it. That would be the value of this expression, this numerical expression. We haven't gotten to variables yet. All right, so let's take a look at number 40, where we have another order of operations problem. So keep in mind that when you have a fraction bar, it actually just separates the numerator and denominator into 2 separate pieces. It's like their own grouping symbol, right? So you can really just solve each part separately if you'd like. So 7 plus 15 divided by 3. We can really solve that by itself, and the fraction bar means division, so we're dividing by this 11 minus 3 times this 3. Okay, so again, you can solve them separately. In the first grouping symbol, 15 divided by 3 is going to be 5, so we really have 7 plus 5. And 7 plus 5 is going to be 12, so that's going to be the answer to the numerator. And let's go ahead and check the right side here. So 3 times 3 is going to be 9, so that's going to be 11 minus 9. And 11 minus 9, we can go ahead and solve that. That's going to equal 2. And all along the way, we needed to divide whatever those answers were. So 12 divided by 2 is going to equal 6. That would be the value of this expression. Okay. Moving on to 41, we're going to go ahead and identify some vocabulary with some algebraic expressions. So terms, like terms, coefficients, Constant terms, these are all all vocab words that you're going to definitely want to know. So terms, by definition, are separated by plus signs. All right. Generally, that's how we think about them. So 4x is a term, 3 is a term, x or 1x is a term. A lot of people forget about the coefficient of 1, but I'm just going to write it to be super clear. But these would be the 5 terms in this algebraic expression. Okay. Some of them are like each other, and some of them are not like each other. And when we say like each other, it just means they either are constants, they just have numbers, or they have the same type of variable. So like terms, let's see, this 4x, 1x, and 7x, they all have x. So those are like each other. Okay, 7x, 1x, and 4x. I don't know why I wrote them out of order, but I did. And then we have 3 and 8. Those are just the normal numbers or the constants. So we can kind of separate them and say, okay, these ones are like each other because they all have x, and say these ones are like each other because they don't have x. They're just normal numbers. Okay. Now for the coefficients. Coefficients, C-I-E-N-T-S, I think. Let me spell that right, hopefully. Coefficients are really just these numbers that are being multiplied by the variable. So it's how many of each variable. So 7 is a coefficient, 1 is a coefficient, and 4 is a coefficient. It's just the number of each of those x's. Okay. Coefficients are always going to be found in front of the variables. Okay. Finally, we have these things called constant terms. Constant. You can call them constant terms or constants. I'm just going to write constants for now. Usually people will know what you're talking about. And those are just the plain old numbers that don't change. The word constant means it stays the same. And 3 and 8, those terms, the value of those terms don't change. Okay. Talking a little bit about, in 42, we have properties. So we have the identity property of addition. And how is it similar yet different to the identity property of multiplication? So the identity property of addition, we call that maybe IPA, identity property of addition. That states that if you take anything like 4 and you add, what's the only number you can add where it stays the same? That's still going to be 4. If you have like -3 plus 0, that's still -3. If we have like x plus 0, that's still equal to x. Right? That's the identity property of addition, where we are adding 0 on. And whenever you add 0, the value stays the same. Now let's talk about the identity property of multiplication. So the only number in the world you can multiply by and keep the same value is going to be 1. So 6 times 1 is going to be equal to 6. -7 times 1 is going to equal -7. If you have something like y times 1 or 1 times y, that's just going to equal y. So the only number in the world you can multiply by and get the same value is going to be the value of 1. So when you're trying to explain how these two are similar, you're trying to really just say that it's the only number you can add or subtract, so the value doesn't change. So that's kind of what they have in similarity. Value stays the same. Okay, so that's really the important idea of these two identity properties. But when it's talking about like what's different about them, right? What's different is, well, 1 is being multiplied and 1 is being added, right? So they're slightly different from each other, but this whole idea of 1s and 0s are super important in math, because 0 is the only number you can add and stays the same, and 1 is the only number you can multiply where it stays the same. All right, let's check out 43, where we have to simplify this expression of 3x plus 8 plus x plus 4 plus x plus 5. So again, we don't know what x is, so that poses a little bit of a problem. So our only real thing we can do here is simplify this, right? And so we're going to combine things that are like each other. So this 3x can be combined with this positive 1x. I'm going to go ahead and write, there's an invisible 1 here from the identity property I was just talking about. And then we have another positive x, which means there's an invisible positive 1 here as well. So combining this 3x plus 1x plus another 1x, 3 plus 1 is going to be 5. That's going to be a total of 5 x's. Okay. In terms of the constant terms, we have this plus 8, plus 4, and plus 5. These are constant. They don't change. 8 plus 4 is 12, and 12 plus 5 is going to be 17. So this would be the most simplified expression here, right? If I were to find the value of this, if I told you x was hypothetically 3, you would plug in 3 and 3 times 5 plus 17. That would be much easier than plugging it into the original expression that we had. All right, this is as far as we can go, or the most simplified version of this expression. Okay, let's try this maybe one more time. If you'd like to pause it and try it on your own, go for it. But we have 2y plus 5 plus y plus 5y plus 4 plus y. Let's see what we got going on here. So whenever you have just a y, it might be helpful just to write in the coefficient if you think you might forget it. So starting with the y terms, we have 2 y's. We're going to add one more. That makes 3 y's. Plus 5 of these, that makes 8 total y's. Plus one more, that's going to make 9y. Okay, that takes care of those ones. Now we have the constants. We have plus 5 and plus 4, and that's going to make a plus 9. So this would be the most simplified expression here. For number 45, we have an algebraic expression here of 4x squared plus 3x plus 8. And we're being told to evaluate it for 3 different scenarios. So the first scenario here is when x is equal to 4, hypothetically, right? And then we're going to find out what the expression's equal to when x is equal to 2. And then we'll do it one more time when x is equal to 0. Okay, we'll see what that expression is going to be. So let's try this 3 different times. Let's start off when x is equal to 4. So when x is 4, we'll change x to 4. So 4 times 4 squared plus 3 times 4 plus 8. Okay, following the order of operations here, exponents come first, so 4 squared is going to be 16, so that's going to be 4 times 16 plus 3 times 4 plus 8. We have multiplication. The left one's going to go first. That's going to be 4 times 16 is 64 plus 3 times 4 plus 8. 3 times 4 is 12, so we'll have 64 plus 12 plus 8. 64 plus 12 is going to be 76, so we'll have 76 plus 8. And 76 plus 8, that's going to be 84. So we just found when x is equal to 4, the expression is equal to 84. So now when x is equal to 2, we'll take 4 and substitute in 2 for x, so it's going to be 2 squared plus 3 times 2 plus 8. Okay, so we'll start with that. Then we go ahead and do the exponent first. So 2 squared is going to be 4. So we have 4 times 4 plus 3 times 2 plus 8. And we'll go do the multiplication to the left here. So 4 times 4 is 16. 16 plus 3 times 2 plus 8. Then we can do the multiplication. 3 times 2 is 6. So we have 16 plus 6 plus 8. And then we can do the left to right. That's going to be 22 plus 8. And 22 plus 8 is going to be 30. So when x is equal to 2, this expression is equal to 30. Again, we're just trying a few different scenarios, right? Expressions don't necessarily have one right answer. It depends on what the variable is equal to. Finally, what about if x is 0? Hopefully this is a little bit less work. So 4 times 0 squared plus 3 times 0 plus 8. All right, cool. So 0 squared is just going to be 0. So it's going to be 4 times 0 plus 3 times 0 plus 8. 4 times 0 is just going to be 0. So 0 plus 3 times 0 plus 8. 3 times 0 is going to be 0. So we have 0 plus 0 plus 8. Just to be thorough, 0 plus 0 is 0 plus 8, and that's equal to 8. So given 3 different values for x, we have 3 different values of the expression. For number 46, we'll take a look at the distributive property here. So distributive property, it comes into play when you have a repetition of something. So we want to notice here that we have this 2x plus 5 plus 2x plus 5 plus 2x plus 5. That's what, 4 of them. And there are 5 of these 2x plus 5. So repeated addition lets us know that we can write things with using multiplication as a shortcut. So we can say this is going to be 5 times the quantity of 2x plus 5. Then we can go ahead and use the distributive property, which states that we have 5 of these 2x's. If you have 5 of these 2x's, that's saying that we really have 10 of these x's. And then you can say that there's 5 of these positive 5's, which means that's going to equal to 25. Okay, so this would be the most simplified expression, but condensing it using the distributive property. Okay. For 47, what if we go backwards here for this expression? So we have 3 times the quantity of 5x plus 4. So again, what does this mean? It means technically there is this 5x plus 4 plus another 5x plus 4 plus another 5x plus 4. Again, multiplication is just a shortcut for addition, so addition is just an expanded version of multiplication. All right, so for 48, we're going to go ahead and try simplifying an expression, but we have to use the distributive property to do so. So I'll write down the expression. It's 4 times this quantity, 2x plus 5, plus the 3x, plus the 2, plus 5 times the quantity of x plus 6. Okay, so we're going to start off and distribute. There are 4 of these 2x's, right? So technically there are 8 x's, and then there are 4 of these positive 5's. So that's really 20. Okay, we're going to add on the 3x, we'll add on this 2, and there's really 5 of these 1x's, so 5 of the 1x's means that we have 5 x's, and then we have 5 of these 6's, so 5 6's mean that's going to be 30. This should kind of look like the expressions we were dealing with earlier where we were simplifying or combining like terms. So 8x can combine with a positive 3x to make 11x, and 11 plus 5 is going to be 16. So we have a total of 16 x's here. And dealing with the constants, we have a positive 20 plus 2, that's 22. And 22 plus 30 is going to be 55? No, sorry, 52. Too many 5's in my head. So this would be the most simplified expression. Okay, so if we were hypothetically given a value for x, I'd rather plug it in here than plugging it into the original expression that we had. All right, so moving on and applying what we've learned in the past for combining with distributive property, let's use some common factors. You should be thinking common factors, thinking GCF right now. And then we have to write 4 different expressions. So, okay, well, what's one thing we could do? We can say we have 1 times this 12x plus 18, right? That's one way to write that since 1 is a common factor. We could say we have 2. 2 is a common factor of these terms, and that would be 2x plus 9, right? That would be the same thing as well. You could say 3. 3 is a common factor. 3 times 4 and 3 times 6. 4 is not a common factor. 5 isn't either. 6 is a common factor. So 6 times 2x gets you 12x, and 6 times 3 gets you 18. Okay, so these are all different ways of writing this expression. And you can notice that if we were to distribute, this would equal 12, that would equal 18, that would equal 12, that would equal 18, that equals 12, that equals 18, that equals 12, and that equals 18. So using the GCF specifically, this is the one that you would use probably more so, but keep in mind that you can rewrite this expression 4 different ways here using all the common factors. All right, on to part 4. So we have this equation of x plus 14 is equal to 54, and we have to find the value of x. So to do so, what we do is we use the subtraction property of equality, meaning we're allowed to take an equation and subtract the same value on both sides. And what happens here is 14 minus 14 is 0, so we have x plus 0, and on the right side, 54 minus 14 is 40. And you might remember from earlier, the identity property states that, anytime you add 0, you don't really have to write it. So we know we can say that x is equal to 40. Okay, you can plug this in and check it if you would like. You can take this 40, substitute it in here. 40 plus 14 does equal 54. That checks out. Okay. For 51, we have this equation x minus 21 is equal to 64. Okay, we can go ahead and get rid of this minus 21 by using the addition property of equality and adding 21 to both sides. If we go ahead and do so, we'll get x plus 0 is equal to 85. And using the identity property, we can drop the 0 and say x is equal to 85. If you wanted to check this, you could take this 85, substitute in here. 85 minus 21 is 64, so we know this is correct. Okay. Moving on down, I'm going to graph these in just a little bit. We have this next equation where we have 6x is equal to 42. So that's 6 times something equals 42. To solve for that something, we need to use the division property of equality, divide both sides by 6. 6 divided by 6 is 1, so we're left with 1x is equal to 7. And by the identity property, we don't need to write the 1 since 1 times anything stays the same. So x equals 7. And finally, one more here. We have y divided by 5 is equal to 13. And so if we want to get 1y, what we're going to have to do on both sides is we're going to have to multiply by 5 on the left, multiply by 5 on the right. The 5s are going to cross cancel on the left, or they'll become 1 over 1, so it'll be 1y is equal to 65. And then we can go ahead and say, by the identity property, drop that 1 and say y is equal to 65. Okay, you can then take this 65, plug it in here for this y. 65 divided by 5 is 13. Forgot to mention earlier, but if you plug this 7 in here, 6 times 7 is 42. So let's go ahead and graph these solutions. It's pretty straightforward. You just draw a short little number line here, and your answer we got was 40, so we put that in the middle, 41, 42, put 2 numbers to the right, put 2 numbers to the left. Usually that's perfectly fine. And our answer was 40, so we just go ahead and fill in a circle on the number 40, and that is the only number on the number line that makes this equation true. Okay. For this next one, if we graph this one, go ahead and graph it. Let's see, 85 was our answer, so we'll go ahead and put 85 in the middle, put 86 and 87 to the right, and we'll put 84 and 83 to the left, and we'll put a dot on this 85. That's the only number that makes this equation true. Okay. Moving on to 52's graph. So we're going to graph this solution here, make a short number line. We'll put the 7 in the middle because that's the answer we got. Put 8 and 9, 6 and 5. 7 was the only answer that works, or the only number that works. So we'll go ahead and fill that in. Okay. Finally, let's graph the solution for number 53. So make a short number line again. Go ahead and put 65, 66, 67, 64, 63, 65 was the number that worked. Okay, that's as easy as that. That's the graph. Moving on. 54. All right, I'm going to graph these as I go because these take a little bit more time. We're going to graph inequalities and solve inequalities now, and then we'll graph them as well. So we have this x plus 5 is less than 9. So there are properties of equality, but there are also properties of inequality. So all that means is that on 2 sides of an inequality, you can add or subtract or multiply or divide the same number. So 5 minus 5 is going to be 0. 9 minus 5 is 4. The identity property says we don't need to write plus 0, so x is less than 4. Okay, so that would be our solution. However, what would this look like on a graph? You would go ahead and you would put your answer. You can put it right in the middle, that's fine. 5 and 6, 3 and 2. And this is where you might need to remember it's open circle or closed circle. X is supposed to be less than 4. It can't actually equal 4, so use an open circle, and it's all the numbers to the left of it will make it true. There's an infinite number of solutions here. So as long as x is less than 4, your answer would be correct, but there's an infinite number of answers. Here's another inequality, and we'll go ahead and graph it as well. So we have y minus 3 is greater than 8. We'll use the addition property of inequality and add 3 to both sides. We'll get y plus 0 is greater than 11. And we can drop the 0 from the identity property. Y is greater than 11. Then we will go ahead and plug 11 in. 12, 13, 10, 9. This one cannot be 11. Y has to be greater than 11. So these are all the numbers that are bigger than 11. Okay, moving on, let's check out some other types of inequalities here. So let's solve this inequality and then go ahead and graph it. We have the inequality 4x is less than or equal to 24. And to solve for x, we have to use the division property of inequality, divide both sides by 4. We'll get 1x is less than or equal to 6, but we can drop the 1 by the identity property and say x is less than or equal to 6. Going ahead and graphing this, 6, 7, 8, 5, and 4. And x is allowed to equal 6, so you fill in the dot, and x has to be less than 6 or equal to it. So a filled in dot means it can be that number, and the arrow means there are infinitely many numbers less than 6 that work. For 57, we have another inequality, and then we will graph it. So we have y over 2 is greater than or equal to 5. And using the multiplication property of inequality, we can multiply both sides by 2. And we'll get 1y is greater than or equal to 10. And we can drop the 1 by the identity property and say y is greater than or equal to 10. Short little number line here. 10, 11, 12, 9, 8. Fill in the circle because y is allowed to equal 10, but it has to be also numbers that are greater than 10. That takes care of some inequalities. Okay. Moving on to 58. Let's see how we do with this. Okay, so we have a linear equation, meaning it's a straight line. We're going to graph it on a coordinate plane. Okay, so we're going to make a table here. So you might be more familiar with starting with the zero or positive numbers, but I'll show you how this works in terms of the pattern. If we say x is 0, okay, that would be y is equal to 3 times 0 plus 4. 3 times 0 is 0 plus 4. That's going to equal 4. So when x is 0, y is equal to 4. What about when x is equal to 1? So we'll say y is equal to 3 times 1 plus 4. 3 times 1 is 3. 3 plus 4 is equal to 7. So when x is 1, y is 7. What about when x is equal to 2? Well, y is equal to 3 times 2, just keep switching out x, plus 4. 3 times 2 is 6 plus 4. That's going to equal 10. So that's going to be 10. What about when x is equal to 3? Y is equal to 3 times 3 plus 4. That's going to be 9 plus 4, and that'll be 13. Okay, so even if you don't know how to deal with negative numbers yet and multiplying negative numbers, don't worry about that too much. Just notice the pattern here, because linear equations always do this. It's going to be adding 3, adding 3, adding 3, adding 3. And that is a common attribute of linear equations you want to know. So what number would add 3 to get you this number? That would have to be a 1. And if you were to add 3 to this, this might be a little bit trickier, but it has to be negative. It's going to be negative 2, okay? And then if you're going to go back 3 again, or subtract 3, would be at negative 5. So the left side might be a little bit more confusing, and if you're only comfortable with quadrant 1, that's fine. But in Algebra 1, you'll start to get more used to this, okay? Plotting the points, I'll go from left to right, so negative 3, 1, 2, 3, 1, 2, 3, 4. Here's negative 3, comma, negative 5. That takes care of this one. Negative 2, comma, negative 2. That's over here. Negative 1, comma, positive 1. It's right here. 0, comma, 4. It's over here. 1, comma, 7 is here. 2, comma, 10, 8, 9, 10 is here. And 3, comma, 13, I don't think I can fit it, but that's okay. Again, we're looking for a graph here, and I think we have more than enough dots to show where the graph is. So something like this would be perfectly fine. Okay? Just keep in mind, linear just means straight line, and you'll spend a lot of Algebra 1 talking about linear equations. Okay? Constant rate of change. Okay. Part 5, talking about ratios, rates, and proportions. So write the ratio of cats to dogs. So cats comes first, dogs come second. Keep in mind we can use the colon to represent the 2. In 3 methods, there are 54 dogs and 72 cats. So it has to be cats to dogs. So it has to be 72 first because it's cats to dogs. And then dogs there's 54. Simplest form using 3 methods. Let's use the latter method here. I can divide both of these by 9. 9 times 8 is 72. 9 times 6 is 54. Divide these both by 2. That's going to be 4 to 3. So it asks for 3 methods. So 4 to 3, that's using words. 4 colon 3, that's 4 to 3. And then 4 to 3 using a fraction bar. So these would be the 3 different ways of writing the most simplified ratio of cats to dogs. Not dogs to cats, but cats to dogs. Okay. The next one is the ratio of likes to dislikes is going to be 8 to 1. So likes are more, dislikes are less. 3 equivalent ratios representing the same ratio. Okay. So we could have 8 to 1. I'll use fraction form here. That means 8 likes Alrighty, here this is likes, and then this is dislikes. So we need to come up with 3 equivalent ratios. So I don't know, times 9 times 9. So an equivalent ratio to this would be if you had 72 likes to 9 dislikes. That's technically the same value. If you want, you can multiply this by something. I'll multiply these by 3. What's 72 times 3? I don't know why I chose these numbers. 210, I think 216 to 27. Technically, that's the same ratio. And maybe for good measure, I'll multiply them both by 100 to keep the same ratio here. So this would be 21600, so 21,600 likes on something. But that means to keep the same ratio of dislikes, you have to have 2,700 dislikes. So these are all 3 equivalent ratios of 8 to 1. As long as you do the same thing to the top and bottom, you're going to get an equivalent ratio. 61, if Benny eats 18 treats in 3 days, write 3 equivalent rates to represent this relationship. Okay, so 18 treats, and that's in 3 days. If you want to label that, that's fine. We have treats, and we have days. 3 equivalent rates, well, they're both divisible by 3. That's a common factor. It's actually the greatest common factor. That means he's getting 6 treats in 1 day. That's 1 equivalent rate. Let's do times 5 times 5. What does that mean? That means that he would be eating 30 treats in 5 days. That's another equivalent ratio. And what's another technically equivalent one? I'll use a decimal here just to show you that you can have that technically. This would be 15 treats in 2.5 days. So can you have decimals? Yeah, we generally try not to, but it's definitely possible. So I just wanted to show you. For 62, we have Mila running 24 miles, and that's going to be in 6 days. So that's a rate, and it says let's find his unit rate per day. So per day means you have to get it per one of them. So we divide them both by 6 because 6 divided by 6 would be 1 day. And 24 miles divided by 6 would be 4 miles per day. This would be the unit rate right here. Unit rate just means per one. Okay, let's go on to 63. We're going to set up a proportion, which is just when a ratio is equal to a ratio or rate is equal to a rate. And then we're going to solve for an unknown. Chloe eats 8 pieces of candy in 12 days. So there's 2 variables here. There's candy, and then there's days. So 8 pieces of candy, that's in 12 days. It says how many days does it take her, so we don't know the days, to eat 36 pieces of candy. Okay, so somehow this ratio on the left is equal to this ratio on the right. One thing you can do is figure out 8 times what gets you 36. 8 times 4 is 32. That's 4 too little. 8 times 5 is 40. That's 4 too much. So it's going to be times 4.5 because that's right in the middle. And then if you do that on the bottom, you got to do it to the top. Times 4.5. 12 times 4 is going to be 48. 12 times a half is 6. So that's going to be 48 plus 6. X would equal 54. So it would be 54 days. That's how long it would take for her to eat that much candy. Okay. Another way you could have thought about this is you could simplify 8 over 12. You can divide them both by 4, and you could get 2 and you could get 3, right? So the new ratio would be 2 to 3 is equal to 36 to x. And if you want to do it this way, that's fine. But then 2 times 18 would get you 36. And then 3 times 18 would get you x. And that's also 54. So I know you could simplify by other numbers as well, but that's perfectly fine. For 64, let's talk about percents a little bit here. So you might remember something like A over B is equal to P over 100, or is over of is equal to percent over 100. If that rings a bell, wonderful. 32 is, so that's the is. That's going to go on top. It says what percent. So what percent, we don't know P, so we'll go ahead and leave that alone. And it does say over here of 40. So that 40 is going to go down here. And it's always 100 going to be in the problem. So that would be the proportion we would set up here. And you could see how many times 40 goes into 100, but I like to try to simplify first if we can. I'm going to try and simplify this ratio on the left by using their GCF, dividing them both by 8. We're going to get 4 and 5. And why that's nice is because 5 times 20 goes into 100 perfectly. So then 4 times 20 would get you P. So P would equal 80. So the answer here is going to be 80%. So if you got a 32 out of 40 on a quiz, that would be an 80%. Or if you made 32 out of 40 free throws, that's an 80%. That's basically what we just found out here. Okay. For this next one, it says what is. So we don't know what the is. That's the above number. So that's A. 100 is always here. It does tell us 60%, so that's always over 100. Percents are per 100. And then it says of 35, so the of goes on bottom. And so that's what we're starting off with here. Okay. I don't know what 35 times what equals 100 perfectly, so let's try to simplify the ratio on the right. So we can divide them both by 10 to make it 6 over 10. Divide it both by 2 to get 3 and 5. So how does 5 become 35? Well, 5 times 7 gets you that. So 3 times 7 would get you the value of A. So A would equal 21. So 21 would be 60% of 35, right? So if there were 35 questions on a test and you got a 60%, that means you must have gotten 21 correct. Okay. Let's move on to one more. Let's do the 48 is. Remember, it's is over of, so 48 is going to go on top. And 75%, well, that's percentage. It's P over 100. And we don't know the whole. It says of what number. So we knew this, and we don't know this. Simplifying this ratio on the right, 75 and 100, you can divide them both by 25. We'll get 3 and 4. 3, you can use long division or use a calculator, but 3 times 16 is equal to 48. And 4 times 16 would get you what B is. So B would equal 64. 64 would be the of or the whole here, the total. So if you got a 75% of something and you got 48 questions right, there must have been 64 questions total if every question's worth 1 point. Okay. 67, you're at a store and something's going to cost $70. It's on sale for 20% off. What is the sale price? Okay, so basically, you know the original price of it is $70. So if you're getting 20% off, so there's a couple ways to think about this, but what's 10% of it? 10% is going to be equal to, or 10% of $70. That's just moving the decimal over one spot. So that's a $7 discount. So that means if you have a 20% of 70, it must be double that. So that's going to be $14. So that's the discount you're going to have. So that's going to be $70 minus the 14 that you're saving. It's going to be 56. So the sale price is going to be $56. Okay. Another way to think about this is you could also, if you have 20% off as the discount, you could just find 80% of 70. And the way that works is 80, if you convert that to a decimal, that's just going to be 0.8. Of means multiplication, so it's times 70. So 8 times 7 is going to be 56, and you have a 0. But since you have one decimal place here, you need to have one decimal place here, and you also get 56. A couple ways of thinking about it. 68, your meal at a restaurant is going to cost $27. You're going to leave a 20% tip and pay 7% tax, both on the original cost of the meal. What's the total cost to the nearest penny? Okay, so you have this $27. You're going to pay for 100% of the meal, and then you're going to pay for 20% to the tip, plus another 7% for tax. So this is really just 27 times 127%. Okay, since everything's of the original meal. You can think about this using distributive property as well, where you're paying for 100% of the meal, then you're paying for 20% of the meal for the tip, and you're going to pay for 7% of the meal for the tax. Converting 127% to a decimal, that's going to be 1.27. And I can't do this in my head. So 1.27 times 27. Don't know why I chose those exact numbers, but they match. 7 times 7, hopefully you know your standard algorithm, that's 49, carry the 4. 7 times 2 is 14, plus 4 is 18, carry the 1. 7 times 1 is 7, plus 1 is 8. Okay, then moving on, we're done with these. Go on to the 2, which is a 20. 2 times 7 is 14, carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 1 is 2. Then going ahead, we have 9, 12, 14, and 3. And we have 2 decimal places and 2 decimal places. So this final price is going to be $34.29. Including tax and tip, this would be the total cost. For part 7, we're just going to do a little bit of statistics, not too much here, just reviewing the basics, all the important stuff you need to know for the most part. So to find the mean, let's start with that of all of these numbers. To find the mean, that's going to be the average of all the numbers. So to do that, what we're going to do is 8 plus 6 plus 9 plus 0 plus 1 plus 4 plus 2 plus 18. You add up all the numbers and divide by the number of numbers. It looks like there's 8 students. And so we add these all up. 8 plus 6 is 14, plus 9 is 23, plus 1 is 24, plus 2 is 28, plus 2 is 30, plus 18, that's 48. 48 divided by 8, that equals 6. So the mean is equal to 6. What about the median? Well, for the median, that literally means the middle. And we start off by writing the numbers from least to greatest. So 0 comes first, then 1 comes second, then 2 is third, then 4 is next, then 6, then 8, then 9, and 18. So the median is going to be the middle. So we have your bottom half is here, and then your upper half here. So the median would have to be right smack in the middle, so that would be 5. 5 would be the median here. As for the mode is going to be the most frequent, M-O-D-E, the number with the highest frequency. None of these repeat more than others. None of them are more special than others, so you can say not applicable or there's no mode here. Okay. Moving on to the range, this one's super straightforward. For the range, what we're going to do here is we're going to take the max minus the min. So the highest number is 18, take away the smallest number is 0, so 18 is going to be the range. And the mode here was nothing, didn't exist. Now for the mean absolute deviation, if you remember, this is called the MAD. The MAD is the one that takes quite a while to do. So you have to find out all of each number's deviations from the average. So good thing we already found the mean, which was 6. So how far, let's go ahead and write these numbers down. So we have to see the average is going to be 6 here. So let's see how far each of these numbers are. 8, 6, 9, 0, 1, 4, 2, 18. We have to see how far each of these are from this average of 6. So 8 minus 6, and it's the absolute value of it. So 8 minus 6 is 2. The absolute value of 2 is 2. How far is 6 from 6? That's going to be 0. How far is 9 from 6? That's going to be 3, and the absolute value of that is 3. 0 minus 6, the absolute value is going to be, well, it's negative 6, but then the absolute value is positive 6. 1 minus 6 is going to be negative 5, but the absolute value makes it 5. 4 minus 6 is going to be negative 2, but the absolute value is positive 2. 2 minus 6 is going to be negative 4, but the absolute value is positive 4. And 18 minus 6 is going to be 12, and the absolute value of that is going to be 12. So these right here are called the absolute deviations. This is like where the A and the D come from for the mean absolute deviations. And we just now have to take all of these numbers and average them. So these numbers here are what we call the absolute deviation. So it's the A and D for the MAD for mean absolute deviation. And so what we're going to do now is take these numbers and then find the average or the mean of them. That's where the whole MAD will come into play. So 2 plus 0 plus 3 plus 6 plus 5 plus 2 plus 4 plus 12. We have 8 deviations, 8 absolute deviations, and divide by 8. 2 plus 0 is 2, plus 3 is 5, plus 6 is 11, plus 5 is 16, plus 2 is 18, plus 4 is 22, plus 12 is 34, I believe. So we have 34 over 8. 8 goes into this 4 times because that's 32 with 2 left over. So that's going to be 2 over 8. So it's either 4 1/4 or 4.25. This right here would be the mean absolute deviation. Alrighty, one more question on statistics. State that which of the following are measures of center versus measures of variability. So measures of center here. So let's go ahead and say measures of center. Mean, that's a measure of center. Measure of center. Median is also another measure of center. And mode is a measure of center. Okay, these are all measures of center. In terms of measures of variability, that's saying how far are things spread out. The range, big range means it's very spread out. Small range, not very spread out. Mean absolute deviation, it's on average how far things are from the average. So that's letting you know how far things are spread out or how variable they are. And the IQR, that's from box plots. That tells you where like the threshold is for the bottom 25% and upper 75% or upper 25%, however you want to think about it. And it tells you how spread out the middle 50% of the data is. So you just want to know some statistical measures are helping you find the middle, and some are telling you how far that data is actually spread out. Okay. Part 8, just a few questions here on geometry, last few questions, and let's get to it. So we have a rectangle here, and we have 3 points. We have to determine the 4th point. So I think probably the easiest way is to kind of show you what this looks like graphically on an XY plane. That might help. But there is like a shortcut as well I can show you at the end. And so -4, 2, 3, 4, 1, 2. That's 1 point. 5, 1, 2, 3, 4, 5, 2. That's here. 5, -5. So 1, 2, 3, 4, 5 is here. So they're telling us these are the 3 points. And so they're telling us where's the last point. So here is one side of the rectangle. Here's the last side. And so the question is like, where's the last corner? So hopefully it makes sense that it has to go down this much and has to go across this much, right? So where is this going to be? Well, it has to be below this dot right here. It has to be below this one. So what x value does this have? This x value is -4. So this x value also has to be -4, right? What about the y value? Well, you have to see how far down this dot is over here. Well, how far down is this? This is at -5 for the y value. So this also has to be -5 for the y value. Okay, so I'll write all these numbers in here, but this is -4, 2, right? That's what we had up here to the upper left. And then for the upper right, this dot over here, this was 5, 2. And then down for the bottom left, we had 5, -5, right? So if you notice, you can just see like what matches here. So these -4s have to match, okay? Every pair that are next to each other, these have to match. On top of each other, the x's have to match, and next to each other, the y's have to match. So that has to be true each time. So if that makes sense, hopefully you can see that as you go around the rectangle, they have different x's or y's that match each time. So the last coordinate here is going to be -4, -5. Okay. For 72, we are talking about a parallelogram. So you want to remember what a parallelogram is. It's just a 4-sided shape that has 2 pairs of parallel lines. And the formula for all area of parallelograms is the base times the height. So if we know the base here is going to be 8 units, then we can say the area is going to be this 8 units. And we're going to multiply that by whatever the height is. So if we see the height here is 6 units, then we're going to multiply that by 6 units. 8 times 6 is 48, so and then 8 times 6 is 48, so we're going to have 48 square units, or 48 little squares would fill up this parallelogram. Okay. For 73, we have a triangle. So hopefully you remember the formula, but if not, the area of a triangle is going to be 1/2 times the base times the height. Or you can say area is equal to base times height divided by 2. Either one's fine. You can use these formulas. And so the base here is going to be 5 units. So it doesn't really matter which formula you use. I'll use, I guess, this one over here. So that's going to be 1/2 times the base. So the base is 5 units. And then we're going to multiply that by the height, which is going to be 9 units. Okay. 5 times 9 is 45, and half of 45 is 22, so 22.5 units squared. That would be the area of this triangle. So let's check out 74. Looks like we're talking about some surface area, and the surface area of the shape we're talking about is a right rectangular prism. They tell us the length is going to be 5, and the width is going to be 6 here, and then the height is going to be 3. So let's see if I can sketch something that looks somewhat resembling what they're telling us. So here is that, and then we have the width, or the length is going to be 5 units. The width is 6, so it's got to go back pretty far. Maybe something along the lines of this. It's not perfect, but that's okay. 6 units and a height of 3 units. If you want to check this out like 3D wise, it's going to look something along the lines of this. So you can see the back corner, okay? And we have to find the surface area, which is the area of all the surfaces. So on the bottom, we do have this rectangle that's 6 by 5. So 6 by 5, that's the bottom. On the left and right side, well, let's see, the front, there is a 5 by 3 on the side, 5 by 3. And this is also a 5 by 3. On the back, what do we have here? Is that 6 by 3? I think so, yeah, 6 by 3. 6 by 3, and then we have another one here that's 3 by 6. And then there should be another 6 by 5 that's hanging out on top. So 6 by 5. Okay. If you're going to find the area of this rectangle, it's going to match this one. So that's going to be 6 times 5 is 30, so 30 times 2 would be 60 square units for those two. Then you have 3 by 5, that's 15, and you have 15, and you have 2 of those, so 15 times 2 is going to be 30. And then finally, 3 times 6 is going to be 18, and there's 2 of them, so 18 times 2 is equal to 36. So these are the areas of all 6 faces of this shape, or all 6 sides. And you can go ahead and add them up here. 30 plus 60 is 90. 90 plus 36 is going to be 126 units squared. This would be the surface area of this box. So if you were to take wrapping paper, this is how many square inches would take up the outside of this present if you were wrapping a present. Okay. And finally, for this last question, we have the volume of a right rectangular prism with the same dimensions that we had earlier. So it has 5 units over there, going by 6 units again, and going by 3 units up and down. So let me just show you visually what this is going to look like. I'm going to just go ahead and copy and paste. Oops. I'm going to go ahead and just copy and paste this shape that we had earlier. I forgot one of the lines. Here it is. And what we're going to do here is I'll show you what this kind of looks like. So the length of 5, that means we have kind of 1, 2, 3, 4. So we have 5 columns here. And if I draw these back, you can kind of see those are the 5. In terms of the 6, that's going to be the width. So if I break it in half, that's 3 over there, and that's 3 over there. And so we can go ahead and draw these lines, 2, 3, 4, and 5. So there you go. You can see like that's the 6, but then for the 3, that's telling us like how much we're stacking up and down. And so it would look something along the lines of this. And so you can hopefully see all the little cubes that are happening here. So volume is really asking the question, how many of these little 1 by 1 by 1 cubes are in there? The way to do that is you find the area of the base and you multiply it by the height. For the base here, it's going to be length times width and then multiplied by the height. So 6 times 5 on the bottom will get you how many cubes there are, and then there's 3 layers of them. So 6 times 5 is 30, 30 times 3. There are 90 of these little cubes that fill up this figure. So that's the volume. Volume by definition is how many of these little unit cubes can fill up the space. And there you have 75 different questions that hopefully summarize pre-algebra, little kind of overview of everything that kind of went down in pre-algebra. And I hope this was a good resource to kind of just get your mind ready for school and give you a little bit of review and flashbacks to all the different types of things that you learned in 6th grade to help you have a successful school year. So if you found this video helpful, you can let me know in the comment section down below. Maybe click that like button, consider subscribing. And as always, I wish you the best of luck and keep up the great work.